Hi, everyone. Thanks for tuning in. My name is Sarah Wodes. I am a senior machine learning engineer here at Currence, and welcome to a series of videos where we're going to be taking you behind the scenes of how we build things. So starting with the enrichment agent, which is how we find, clean, and aggregate messy energy data. So I'll take you first through the problem, our solution, the enrichment agent, and why you should care. So the problem, one, energy data just lives everywhere, from news publications to developer spec sheets, regulatory filings. It's everywhere, it's messy, it's hard to find. Every sector is also different. So data centers need fields like powering models, redundancy tiers, while power projects need information like their interconnection status, capacity. Traditional AI providers just haven't been doing the trick. While readily available deep research agents are amazing, they don't have that specific knowledge that our researchers have been cultivating over the years. And custom sector enrichment is slow. A unique solution for every individual sector would be expensive and really hard to scale. So the solution, we wanted to build one singular flexible architecture that works across any sector, any source, that has tested tools built in that source trustworthy and accurate data. So how we came up with the idea, most popular and successful agents, including Claude Code, share a pretty similar straightforward architecture, which is a while loop that makes tool calls. If you don't know what a while loop is, that's okay. Hopefully it'll make sense by the end of this segment. So each iteration takes an input. So first we pass in the current state. Then that gets sent to the LLM. The LLM, if it already has the answer to the question that was in that input or whatever else it needs for the output, will return that. If it doesn't though, it will call a tool to help it find that output, whether it's a specific search or a specific skill. And it'll keep looping and calling tools until it gets the answer and the output that it needs. And that's the wild part. Until we have the answer, keep making the loops of tools. So enter Currence's enrichment agent, pretty similar structure. And this is boiled down a little bit, but really builds in some of that extra research knowledge on top of the while loop. So we take input data, an RSS feed, an Excel, a spec sheet. We clean it up, we normalize it, which we'll talk about in a different video, but then we tag it to a sector profile. So for example, if the source is coming from a data center developer spec sheet, we know to tag it to the data center profile, versus if it's coming from an interconnection queue status sheet, then we know to tag it as a power project. That profile is going to determine what kind of fields we want to collect, what specific tools we want, some extra prompt context that we give the LLM depending on what the sector is. Then gets fed into that black box, the LLM, and it will try and find the values for all the fields we requested. So it'll go through once, it'll ask, did we find all the fields? If it didn't, we'll see if there's any more tools that were defined in the profile that we should run. A really simple example is, hey, we have an address, but we don't have the coordinates yet. So run our geocoding tool. It'll run the tool, it'll feed it back into the LLM, and it'll keep doing that loop until we get all of the profile values. We added another element though, because we found that sometimes in the middle of this loop, we actually unlock more data collection. So for example, when we're collecting information about data centers, sometimes we are struggling to find equipment data. So what kind of equipment, what kind of generators, etc., the data center is using. So if we find that a data center is located in a specific state in the US, for example, Texas, then we know that sometimes they have to submit air permits if they're going to be above a certain level of pollution. So we'll then go and search the TCEQ, the Texas Registry of Air Permits, and see if we can find any information about that data center. If so, we process it, we load it, and we feed it into the LLM to keep trying finding more of this information in fields. Once all of that is done, it goes to a final step where we synthesize a few things like a really great overview and description of the project, and then we get the output. So a real example of what that looks like, we might be taking in data from the spec sheet. It gets fed into the agent, which is built on Python. And then we have the output, which this is a real example of a project page on the Currence platform. You can see things like specific site information. You can see what scale the data center is at, what development type it is, the capacity, the power supply, and even more. So why this matters, energy market intelligence is only as good as the data behind it, which means that we want data that we can trust, that we can source. So by integrating the research that you know and trust at Currence, I'm sure you've seen our Currence researchers on webinars, you've seen them out in the wild doing conferences. And they're some smart cookies. So by integrating their knowledge and their expertise into our agent means that our data is going to be comprehensive, consistent, traceable, that you can trust it. So for you teams out there that are building and financing the energy system, this is the absolutely critical foundation that all of your other analysis is going to be built on. So with that being said, let's build together. If you have ideas about the enrichment agent, you want to know more, please reach out to our sales team. Find me on LinkedIn. Would love to connect and hear all of your ideas and thoughts. Thank you.